Hi students, this is the problems discussion of the fast track revision series for JEE Main, Coulomb's law, part 2. In the last video, we have discussed few questions. Now, some other questions we are discussing. This question is based on the principle of superposition. When multiple charges are placed, then how to find the force experienced by any one particular charge due to all other charges. Now, in this question, it is mentioned there are three charges Q, capital Q, and plus Q respectively at the distances 0, d by 2 and d from the origin. Means say this is the origin 0, this is d by 2 and this is also d by 2. If the net force experienced by plus Q placed at x equal to 0, it means if the net force experienced by this charge particle is 0, means this first charge particle and circle charge particle, then what is the value of the small q? Means we have to find the value of small q so that the force on this charge plus q placed at origin is 0. So here we'll use the principle of superposition. Let's find. Now plus q will experience the force due to this small q and due to the charge placed at x equal to plus d. The force experienced by small q due to q is 1 upon 4 pi epsilon naught q upon d square by 4. And the force experienced by capital Q at the origin due to capital Q at D is given by KQQ upon D square. Now the vector sum of these two forces will be 0. So let us say I am calling it as F1 and it is calling it as F2, and I am assuming both F1 and F2 are in the same direction. F1 also in the same direction and F2 also. Then total force will be equal to F1 plus F2, and it comes out to be K upon D square common, capital Q also common, 4Q plus Q. And this must be 0 because it is given in the situation. Now, from this particular condition, we can say 4Q plus Q is equal to 0. That is, Q is equal to minus Q by 4. Now you see, in vector form, we have got the answer with sign. So your answer will be third option. Now take the next question. This question is also based on the principle of superposition, but slightly different. Here they are saying 3 point charges are there. Q1, Q2 and Q3. 3 point charges are given. They are saying you take them such that Q1 and Q2 are placed close together to consider a single point charge. Means they are considering this is a charge Q1 plus Q2. The force on Q3 at a distance of r from this combination. The force on Q3 when it is placed at a distance of r from this combination is repulsive force of 2F. Now repulsive force we'll write with positive sign and attractive force we'll write with negative sign. You remember this. So repulsive force of 2F is equal to 1 upon 4 pi epsilon naught K. Q1 is Q1 plus Q2 and Q3, and they are placed at a distance of r square, r. When Q2 and Q3 are added, means in place of Q1 plus Q2, we are having Q2 plus Q3. And Q1 is here. The attractive force on Q2. Now the force becomes attractive on Q1 at a distance r is F. So attractive force minus 4F is equal to K Q2 plus Q3 into Q1 upon R square. And same way they are saying when Q3 and Q1 are combined, Q3 and Q1 are combined, and this combination exert an attractive force of minus 18F. So minus 18F is equal to K Q3 plus Q1 on Q2. So Q2 upon R square. So we are having these three equations. Now let us say take R square this side and K also this side. So cross multiplication etc. So from equation 1 we can get Q1 Q3 plus Q2 Q3 is equal to 2F R square by K. So I am writing F R square by K as some constant alpha. So 2 alpha. Now second equation will give Q1 Q2 plus Q1 Q3 is equal to minus 4 alpha. Third equation will give Q3 Q2 plus Q1 Q2 equal to minus 18 alpha. Let us call them as 4, 5 and 6. Add these three equations. 4 plus 5 plus 6 will give 2 times of Q1 Q2 plus Q2 Q3 plus Q3 Q1 is equal to minus 18 minus 4 22 minus 20 alpha. So you got summation Q1 Q2 is equal to minus 10 alpha. Subtract, say this is 7th. 7th minus 4, 7 minus 5, 7 minus 6, you will get Q1 Q2 is equal to minus 12 alpha. Q2 Q3 is equal to minus 6 alpha. Q3 Q1 is equal to plus 8 alpha. By subtracting, this is given by 7 minus 4, this is given by 7 minus 5, this is given by 7 minus 6. Now multiply these three equations. Multiply these three equations. So you will get Q1, Q2, Q3 whole square is equal to minus 12 alpha, minus 6 alpha, 8 alpha. You will get this as Q1, Q2, Q3 equal to 2, 3, 4. 4 3 are 12, 2 are 24 you will get. Now divide these two equations, this equation and this equation. Then you will get Q3 is equal to minus 2. Let us name them. Say this is A, this is B, this is C, and this is D. D by A gives Q3. D by B gives Q1 equal to minus 24 by 6 minus 4, and alpha will also come here, and D by C will give Q2 equal to 24 by 8, that is 3. So you are going to have Q1 is to Q2 is to Q3 is equal to minus 4 is to plus 3 is to minus 2. That is, we can say 4 is to 3 is minus 3 is to 2. 4 minus 3 minus 2. Correct answer will be option A. Now you see, it is a nice question, but these type of question in the exam, students might feel, means it is becoming lengthy, hodgepodge may come. So I will suggest these type of question when you are thinking that it may take more than 2 minutes to solve. Take these type of question in the second phase. You are sure shot can solve. But in the first phase, when you devote the more time to these type of question, you may get, I am getting slow. So don't bring this feeling during the exam time. Let's take the next question. A point charge Q1 equal to 4 Q naught is placed at the origin. Another point charge Q2 equal to minus Q naught is placed at x equal to 12 centimeter. This is x equal to 0. This is x equal to 12 centimeter. Charge of proton is Q naught. Means Q naught is the charge of proton. When proton is placed on the x-axis so that the electrostatic force on the proton is 0. Let us say this is a proton and force on it is 0. And it is placed at a distance of x. And in the question we have to find this value of x only. Now how to proceed this question? Now in this particular question, first of all you have to locate where the charge Q naught will be placed. Now here when charge is positive, you can remember some things. If the charges are of same nature and you need to place a charge which experiences the zero force, you have to place the charge in between them. But if the charges are of opposite sign, these two charges are of opposite sign, and you have to place this charge so that it experiences zero force, then you have to place this charge outside these two charges. Outside these two charges, you have to place this charge. And that too towards the smaller charge. You have to place this charge towards the smaller charge. So I hope you will remember this point. Now, the net force experienced by Q naught has to be 0. Here I am not using the vector equation. The force due to 4Q naught experienced by Q naught will be, say, F1. Then F1 will be towards right. F1 is equal to 1 upon 4 pi epsilon naught 4Q naught into Q naught upon x square. And the force experienced by Q naught due to minus Q naught will be towards left because they are oppositely charged, attractive force. And F2 will be equal to 1 upon 4 pi epsilon naught Q naught, that is Q naught square upon 12 centimeter square. Right? Now, the resultant of these two forces is 0. Since they are opposite direction, this F1 minus F2 we can do. So 1 by F1 minus F2 when we will do, it will become 1 upon 4 pi epsilon naught common, Q naught square common, then 4 upon x square minus 1 upon 12 square. This becomes 0. And from this equation we can get x square equal to 4 into 12 square, which will give us x is equal to 24 centimeter. This is our answer. So answer will be 24 centimeter. Right? Take the next question. Four identical point charges are each of same magnitude q are placed at the corners of a square of side A. Let us say we have one square Then charges are there, Q, 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 Q. Side length also given as A. Now they are saying find out the net force experienced by any of the charge. Let us say take this charge. We have to find the net force experienced by this charge. Net force experienced by this highlighted charge. So we are going to find the net force experienced by this charge. This will experience the force due to the charge 1, 2 and 3. The force experienced by this highlighted charge due to 1 will be in this direction. Say it is going to be F. The force experienced by highlighted charge due to 2 will be in this way. Say it is F1. And due to 3 is this direction. Due to 2 and 3, same magnitude will be there. So I am writing F1 only. So the value of F1 will be 1 upon 4 pi epsilon naught Q square upon A square. Right? And value of F will be 1 upon 4 pi epsilon naught Q1 Q2 upon this distance will be root 2a. So root 2a whole square will be 2a square. Now the resultant of F1, this F1, this one and this one will be along this direction only, So what will be the resultant of those two F1 will come? Root 2 F1 along the direction of F. So another force will come here, resultant of F2 F1s as root 2 F1. So the net force experienced by any charge at the corner is, charge at any of the corner is F plus root 2 F1. And this F is, you can add it, KQ square upon A square common 1 upon 2 plus root 2. So this is the net charge experienced by charge placed at any of the corner. Right? Now let's move to the next question. Infinite number of charges are there, point charges, each carrying 1 microcoulomb charge. Say this is origin. Each carrying 1 microcoulomb charge are placed along the y-axis. You assume this is the y-axis. Generally we take x-axis, but assume no problem. Along the y-axis at y equal to 1 meter. This is a 1 meter, 2 meter, 4 meter, 8 meter and so on. Total force 1 microcoulomb charge is kept here at every point. This is 1, this is 2, this is 4, this is 8 and in this way infinite charges. And here at the origin 1 coulomb charge is placed. We have to find the force on the charge placed at the origin. So force on the charge placed at the origin will be due to first charge, due to second charge, due to third charge and so on due to all infinite charges. Now the force experienced by 1 coulomb charge due to all the charges will be in the same direction. So here no need of vector sign, simply we can add them because all the forces are in the, all the vectors are in the same direction. So 1 upon 4 pi epsilon naught common, 1 coulomb charge common, 1 microcoulomb charge common in all terms. Only distance left 1 upon 1 square plus 1 upon 2 square plus 1 upon 4 square plus 1 upon 8 square and so on up to infinity. Now this is an infinite GP with common ratio 1 by 4. 1 by 4, 1 by 16, 1 by 64. So this way. So what we are going to have 9 into 10 to the power 9 into 10 power minus 6 into sum of infinite GBs A upon 1 minus common ratio 1 by 4, right? It will become 4 by 3. 4 by 3 means it will become 3 into 4 into 10 power 3. That is 12 into 10 to the power 3 Newton. They are saying this as x into 10 to the power 3 Newton. So the value of x they were asking. So value of x will become 12. 12 will be your answer. Right? Now take the next question. 5-point charges are there. Each of value q are placed on 5 vertices of a regular hexagon. Now in this question, one hexagon is there, regular hexagon, like this, regular hexagon. 5-point charges are placed on 5 vertices. 1, 2, 3, 4, 5. And one charge is placed minus q at the center. And at the center, one charge is kept minus q. Now they are saying what is the net force experienced by the charge placed at the center. Now in the hexagon, this side is L given, and we know the distance from the center to any of the vertex in the hexagon is same as the edge length L. Now try to see. Actually diagram is not very proper, but now this charge particle and this charge particle are exactly diametrically opposite. So what is happening? This charge exert a force on this charge in this direction. This charge will exert the force on this charge in this direction. Attractive. This charge particle placed at the opposite corner will exert the force at the center in this direction. Means the force because of this charge and this charge experienced by this will be cancelled. And when they are getting cancelled, the force due to these two, 0. Same will happen due to these two. So it means that central charge will experience the force only due to this charge. And it will be in this direction, away from the vacant corner. And the answer will be 1 upon 4 pi epsilon naught q square upon L square. This is the answer. Now let's take the next question. In this question, it is given there are two positive point charges, each of magnitude q, which are located at a distance 2a. This is one charge, this is another charge, and this separation is 2a. Now they are saying one test charge q naught is located. One test charge q naught is located here. Q naught is located here in a plane which is normal. This is the plane we have shown, the normal to this particular line. And this is midway between them, means it is passing through the midpoint here. This is what it has been shown. Now we have to find the locus of the points where the test charge will be placed so that the force on it is going to be maximum. Means we have to find the locus of that point in this plane, in this circled plane, where the force experienced by Q naught will be maximum. So this is the arrangement. Now let's coming to the how to proceed this question. Now it is mentioned there are 2-point charges. So Q which are fixed, and there is another point charge, test charge Q naught, which is kept in the plane normal to the line joining them and passing through the midpoint. So here it has been shown. So what I am trying to do, I'll find the force experienced by test charge due to this charge and due to this charge. Let us say the force experienced by this left charge at the test charge is F, and same magnitude will be due to the right charge F. So this is due to the left charge, this is due to the right charge, and the magnitude of this force will be F equal to 1 upon 4 pi epsilon naught capital Q small q upon r square. R is under root a square plus x square. Now this force can be resolved in this direction and this direction. Now this component will be cancelled by this component. So the net force will be only in this particular direction. And this net resultant force will be F cos theta cancel 2F sin theta. So net resultant force is 2F sin theta. Its sin theta value is equal to, from here, x upon under root a square plus x square we have find. Now we have to find the locus of that location of this point charge so that the force is maximum. So for maximum minimum, to find out whether the force is maximum or not, we'll use the concept of maxima minima. So we have differentiated this expression dfr by dx. I can say dfr by dx, and this is going to be, after differentiating, we will get this particular expression. For maximum, we have kept it 0. So it will become df by dx equal to 0. Then we'll get x equal to plus minus a by root 2. It means when the particle is placed at a distance of x by root 2, this one, then the particle is going to have the experience the maximum force. So now they are asking the locus in this plane. Now if we see at this particular point, now try to observe this point. If at this point they are experiencing the maximum force, then all the points which is at a distance of x from this particular point, they will lie on a circle. They will lie on a circle, and hence we can say the locus of those points where the force experienced by test charge is maximum is going to be a circle, and it will be a circle of radius a by root 2. So your answer will be 90, option A. Let's take the another question. Now this question is previous year JEE main question, and it is very much similar to the last question. Now in this question it is given 2 point charges capital Q each are placed at a distance d apart. Means like in the previous question given at a distance of 2a. Now in this question it is given d apart. So here 1q, 1q, and this is d by 2, it is there. Now third point charge is placed at a distance x from midpoint on the perpendicular bisector. They are saying on the perpendicular bisector at a distance x, here a third point charge q is placed. Now they are asking the value of x. Find x so that this point charge force experienced by q is maximum. Now I think you have understood. Nothing we have to do. Force experienced by this will be in this direction. Force experienced by this due to this right charge will be in this direction. Same, just like similar to earlier. So answer will be x equal to d by root 2. No, sorry. It's not d by. Yes, x equal to d by root 2. This answer will come. Right? This is the previous year JEE main question. Now take the next question. That is also very much similar to this only, and it is also the previous year JEE main question. They are saying 2 two equal positive point charges are separated by a line distance 2a. Same thing. Two positive charges separated by a distance 2a. Now, distance of a point from the center of the line joining two charges on the equatorial line at which the force experienced by test charge. Now, language only has been changed. Now, distance of a point from the center. This is the center. From the center of the line joining two charges. From this on the equatorial line. Equatorial line means in bracket they have mentioned perpendicular bisector. On this line, at what distance from here, say x, should we place a test charge so that it experiences maximum force? This is a by, say this is not x because in the question already x, say it is y. Force experienced by q naught is maximum. Then is a by root x. Means they are saying y is equal to a by root x. Then you have to find the value of x. Now we already know y is equal to a by root 2. So x is 2. So this is the answer. Now you see two questions were there, very much similar. Not very much, I can say they are exactly same. Now this is also the question from previous year JEE Main only. Let's see this question also. Now two electrons. Now you see up till now in all the question it was mentioned two positive charges or two charges, but here specifically they are mentioning two electrons are placed at some separation. Two electrons each are fixed at a separation of 2d. So here one electron, here another electron, and this is the separation 2d. A third charge proton placed at the midpoint. Now here third charge one proton is placed. So if I say this is minus E, here I can say it is plus E, is placed at the midpoint. Now they are saying this proton is displaced slightly, by a distance x. Now they are saying this is x, and it is also mentioned x is much less than d. Perpendicular to the line joining the electrons, two fixed charges. Means in this direction we are displacing the charge and released. Then they are saying proton is going to execute SHM. Proton is going to execute SHM in this way, right? So they are saying find the angular frequency of this SHM. So expression will be very much similar like in the previous, but one additional concept of SHM has come. So we know in the SHM, the sufficient and necessary condition for a particle to perform SHM is the restoring force has to be proportional to displacement. Now you see this question, we are solving step by step. This is the equilibrium position, this initial position. Now when the particle has been displaced here, this proton will experience the force due to both the electron, one in this direction F and then again in this direction. Proton will experience the force due to both the electrons, and the value of this F will be 1 upon 4 pi epsilon naught. Charge of the electron and proton I am denoting by E upon d square plus x square. Now if I take this angle as theta, then this angle will be also theta. Then this F, will be in this direction cos theta, and in this direction we have sin theta. Now cos theta component will be cancelled, and the restoring force we are going to have F sin theta, or rather total restoring force 2F sin theta. So F restoring is 2F sin theta. Now substitute the values. I am denoting Fr to 1 upon 4 pi epsilon naught E square upon d square plus x square and sine theta is x upon under root d square plus x square. So we got this 2k e square into x upon d square plus x square to the power 3 by 2. Now this force comes out to be 2k e square upon d cube, d we have taken outside, x upon 1 plus x square upon d square to the power 3 by 2. Now since x is very small as compared to d, so x square by d square is tending to 0. So the resultant force we are going to have 2k e square upon d cube into x. Since the restoring force is coming out to be proportional to x, it is performing SHM with m omega square equal to 2k e square by d cube. That is, frequency of oscillation will come out to be omega is equal to k, we are writing 1 upon 4 pi epsilon naught. So e square upon 2 pi epsilon naught d cube m under root. This will be the answer. E square 2 pi epsilon naught m d cube. So this will be your answer. Now you see almost all the 4 questions were very much similar. So if in a plane on the perpendicular bisector of two fixed charges, they are asking at what particular value of point charge, at what particular distance from the center point, midpoint of the line joining the charges, the force experienced by a test charge is maximum, then you can remember it is going to be A by root 2. Now we are coming to the next question. Now this is also a nice question but very common question. Two small balls, each of mass m and length charge q. There are two small balls, each of mass m, charge q, are suspended from a point, common point, say from here, like here. Two light strings, these two are given as the insulating strings, each of length L. Find the expression for the angle made by any of the strings with the vertical. They are saying find the expression for this theta, means you have to find theta under static equilibrium, under the equilibrium condition. So here only I am drawing the free body diagram. It is experiencing one force mg, one force the tension in the string, and one force the electric force. Now let's find the value of the electric force. 1 upon 4 pi epsilon naught q1 q2 upon separation. Separation means this distance. Now this distance is double of this distance, and this is equal to L sine theta. So we can say 2L sine theta whole square. So this is the electric force. Now this is the situation of the point charge, mg, tension, electric force. Now we can resolve this t in this direction, t cos theta, t sine theta. This is theta. So t cos theta will be equal to mg and t sine theta will be equal to fe. And t cos theta equal to mg. Divide the expression, you will have tan theta is equal to fe divided by mg. Substitute the value of me here, k q square upon 4l square sine square theta into mg. So this is the expression which is going to give us the expression for the theta under the static equilibrium condition. Now consider the next question. Two small spheres, each of mass 10 milligram, are suspended from a point by thread 0.5 meter long. Very much similar situation like in the previous question. Two threads are suspended like this. Both are having the same mass. Length is given as 0.5 meter. They are equally charged, means charge is also same on them. And they are repelling each other to a distance of 0.2 meter, means this distance is given as 0.2 meter. This is also given. The charge on each of the spheres is given, and we have to find that value only. So the same thing, even if you want to use the expression for the above question, we can use. So I'm writing, if this angle is theta, so I'm writing directly t cos theta is equal to mg, and t sin theta is equal to kq square upon r square. Tan theta is equal to kq square upon r square into mg. Now theta will be how much, you see? This is 0.1, this is 0.5. It is given. So tan theta is equal to perpendicular, that is 0.1 upon base. Base is going to be 0.25 minus 0.01. Base is this value, right? So this is the tan theta comes. So 0.1 divided by root 0.24 is equal to 9 into 10 to the power 9 into q square. R is 0.2 whole square. Mass is 10 milligram. So 10 into 10 power minus 3. And G value they have said to take 10. So it comes. So from the, now you have to do the calculation. Find the value of Q. Compare it with the A upon 21 into 10 to the power minus 8 Coulomb. And then get the value of A. This way you can do this question, right? Come to the next one. Two identical charged particles, each having a mass of 10 gram, and charge this to 0.2 microcoulomb area, are placed on a horizontal table with a separation of L between them. Means two charged particles, both having the mass m and charge q. Value of m and q both are given, are placed at a distance of L, such that they stay in limiting equilibrium, means there is a equilibrium between them. Now coefficient of friction is also given. Coefficient of friction is given as 0.25 between the particles and the table. Now they are asking find the value of L. Now why they will be in equilibrium, you see, these two charged particles will exert an electric force on each other. This will be balanced by the friction force. Since they have said limiting equilibrium, it means we have to go for the electric force is equal to limiting equilibrium force. Electric force is 1 upon 4 pi epsilon naught q square upon L square equal to mu mg. Now we can substitute the values. 9 into 10 to the power 9. Charge given 2 into 10 to the power minus 7. So 4 into 10 to the power minus 14. upon L square, what we have to find, equal to mu given 0.25, m given 10 grams, so 10 into 10 power minus 3 into 10. I think in the one of the previous question, 10 milligram I have written as 10 into 10 power minus 3. Change it to minus 6. Milligram means minus 6. A mistake has happened. Now here, coming back to this question. Now from here, then we can get the value of L square as, this becomes 4 square. If I take it this side, it becomes 10 power minus 1. So minus 1 means it becomes minus 13. 9 and 13, it becomes 10 power minus 4. So it becomes 9 into 4 square into 10 power minus 4. So L will become 3 into 4, 12 centimeter. This will be your answer. So these questions, last 3 questions, if you see, they are on the basis of means electric force and some other forces coming. And with the help of that, you have solved it, right? So I can say they are slightly multi-conceptual, but easy question. Let's come to the next question. In this question, it is given a particle of mass m carrying charge q1. One particle is there of mass m and it is carrying the charge q1, is revolving around a fixed charge minus q2 in a circular path. It means something like this. Here one charge is there, minus q2, and here another charge q1, and it is having the mass m. It is moving in a circular path of radius r. Calculate the period of revolution and its speed. We have to find the time period of revolution and speed. Now, if it is moving in a circular path, some force must provide the necessary centripetal force. Who will provide the necessary centripetal force here? The electric force between these two charged particles will provide the necessary centripetal force. So, K, Q1, Q2 upon R square equal to mv square by R. From here, you can get the value of V. Once you got the value of V, let's solve it. There's no problem. K, Q1, Q2 upon M under root. Now the second thing they are asking, find the time period of revolution. Time period of revolution will be T equal to 2 pi R upon V. So 2 pi R, one R left here, K, Q1, Q2. R. 2 pi R upon V. V is K, Q1, Q2 upon MR. So from here you can get the value of the time period also. So this way. Now here the concept involved electric force and slight concept of the circular motion and uniform circular motion. Now let's take the next question. It is slightly different question. Now here it is given 2 point charges are placed at a certain distance r in air. 2 point charges are there. They are placed at certain distance apart in air. This is air. Say Q1, Q2. Then they exert a force F on each other. F is equal to 1 upon 4 pi epsilon naught Q1, Q2 upon R square. Now they are saying the distance R dash. Find out the distance R dash at which these charges, same charges, will exert the same force, means F dash is equal to F, in a medium of dielectric constant K. Now, in this particular dielectric situation, the force will become 1 upon 4 pi epsilon naught K Q1 Q2 upon R dash whole square. Now this f dash and f are going to be equal. So if we substitute this f dash value here, then what we are going to get 1 upon 4 pi epsilon naught q1 q2 upon r square is equal to 1 upon 4 pi epsilon naught q1 q2 into k r dash square. So q1 q2 4 pi epsilon